Hi there. I want us to look at the equation of a line. And we usually say that the equation of a line takes the form y equals mx plus c. So we are looking at the equation of a straight line y equals mx plus c. Maybe you have come across it, that is if you're in form 3 or form 4. But if you're in form 2 and you have not covered the topic with the teacher, we can go through it. So when we say that the equation takes the form y equals mx plus c, this is a condition that is fulfilled by all straight lines. And in this, we say that y equals mx plus c, m and c are constants, where m is the gradient and c the y-intercept. So m is a gradient and c is the y-intercept. So in that case, this is what we mean, that if I have my Cartesian plane right here, right there, my c is the point where, and this is the line. So my c here, this is where I have the c, and there is a point 0c. That is a point 0c, meaning the value of x at this point is 0, and that of y is the constant right here. So I want us to do something more involving and look at or calculate or rather find the equation of the line. So I want us to have our example 1. So find the equation of a line passing through -1, -2, and 3, 5. So that is the equation I want us to look at of a line passing through the point -2, -1, -2, and 3, 5. So the very first thing that we do when we get such a line, we find the gradient, and that one we did in our lesson number 2. So we'll get the gradient of the line. Now I'm going to partition my working space. I want to partition it so that it can fit well. So there we have it. I want us to start working from this part here. So I'll say I have my points -1, -2, and 3, 5. Get the gradient. We were calling this x1, y1, x2, y2, and we're saying gradient should be equal to change in y divided by the change that occurs in x, which we also said is the difference. So y2 minus y1 divided by x2 minus x1. With that said and done, in this case our gradient will be, in this case will therefore be 5 minus -2 divided by 3 minus -1, and therefore 5 minus -2 will get 7, and then 3 minus -1 we get the gradient to be 7/4. And I hope that when we can all see, it's something we had done in our second lesson we are getting the gradient, and now we have the gradient right there. So we are going to use this gradient on this partitioning. The gradient 7/4, and with that gradient I'll pick any of my 2 points. I want to pick the favorable one. I always love working with the positive, so I'll take my point 3, 5, and then being aligned we can take another imaginary point that we always have the coordinate x, y. So I have a known point x, y, one of the points 3, 5, and then 7/4 is the gradient. And I'll say that in that case the gradient is still equal to this change in y over change in x. So say to get this gradient we take y minus 5, that is, we have the x1, y1, x2, y2. So change remains to be y minus 2, y2 minus y1, x2 minus x1. So y2 is y, y1 5 divided by x2, which is x minus 3, should be equal to 7/4. So cross multiply, you get 4 y minus 5 to be equal to 7 x minus 3, that way. So I'll have y minus 20 should be equal to 7x minus 21. So therefore 4y should be equal to, I'm leaving y on one side because here, right here, we said we have the equation of the line takes the form y equals mx plus c. So in this case I'm putting everything else on one side, on this side here, and I'm leaving y on one side. And with that being said and done, I'll have 7x minus 21 and plus 20. So I'll have 7y to be equal to 7x minus 1, divide everywhere by 4, divide by 4, divide by 4, and y becomes 7/4x minus 1/4. And I'll leave my equation at that. So this is the equation of that line passing through the point -1, -2, 3, 5, and I'm leaving it at this point where I have y equals m. So in this case, if I'm asked, my m is 7/4 and c is -1/4. I leave it at that. Yes, leaving it, yeah, at that. That is, I'm leaving it.